In this video, I want to talk about my interests, and specifically what I want to do as a career, for a career, or whatever. Not quite sure what I'm going to title this video, but I'll come to that when I come to that. So I want to be a physicist of some kind, preferably an astrophysicist, or a biophysicist would be my second option. But the problem is, I'm not good at math. I like doing math, but only if there's actually an answer that you're trying to get for some reason, or the answer is somehow relevant. Just solving equations, I mean, that's kind of satisfying, but up to a certain point it becomes so tedious that it overwhelms how satisfying it is. And unless there's some sort of objective, like you're actually trying to find the answer to something like you would use math for in the real world, I just find it boring. Like in math class, where we just solve problems. But so, hopefully I can be an astrophysicist or some kind of physicist, because I like that kind of stuff, but not being good at math, I don't know. But I can certainly talk about it. And the first thing I'm going to talk about is stars and light years. We probably all know that light years is not time, it's a distance, it's a unit of distance. It's how fast light travels in a year, which is 670,616,629 miles an hour. And we can't even travel that fast, but we know that things that are, say, 100 light years away, it will take 100 years before we can see what's going on there now. And of course, by that time comes, it'll be 100 years later, and that information will be out of date. So a star that's 100 light years away, you're looking at the light that left that star approximately 100 years ago. Now, if there's stuff in between it, like nebula, particles, anything that the light can go into and come out of that takes time, then it will be a little bit longer than that. But for the most part, that has to do with whether the light is in a vacuum or not. But when light is created in a star, it bounces like around in the star for a very long time before it comes out. I'm not exactly sure how long, but I'm pretty sure it's several hundred years or more. Like when the light that's hitting us from the sun was created, we didn't exist. So I'm not sure how many years that is, but several thousand years. But for our star, of course, we get closer and further from our star. It takes approximately 8 minutes for light to travel from the surface of the sun after it's left the sun and hit us. And of course, the Oort cloud is about a light year away from the sun. I could be wrong about that, but I'm pretty sure the Oort cloud is about a light year away from the sun. Either that or it's a light year wide, which would be different. That would be the radius. But so if it's a light year away from the sun, then it takes light a year to reach the end of our solar system from the sun. So when we look at a star that looks like it's about to explode, like about to go nova, supernova, then it's very likely that that star is already gone, and the light just has not reached us yet. That's a really interesting thing to think about, because you could be looking at stars in the sky that no longer exist. It's just that their light is still traveling to you, although the actual star itself may be gone. That's pretty interesting. It also means that there's kind of like an edge of the universe. Not necessarily an edge, because there is no edge to the universe as far as we know. But there is a point at which not enough time has passed for light to travel further than this point. That point is what I would call the edge of the universe, because anything beyond that point is not illuminated, and we can't reach it, so there's pretty much no way to detect it. Of course, that doesn't mean it's not there. At the same time, there's other things like the probability of aliens. By aliens, I don't mean things that come and abduct us, because the probability of that is so low that it's like just preposterous. I mean, it could happen, but it'd be like there'd be some huge odds there that the odds would be very small, and the numbers would be very huge. But when you consider that there's 100 billion stars in our galaxy alone, and there's probably 100 billion galaxies in the universe, or more, it's 100 billion times 100 billion, I don't know what that is, a trillion or something? I don't know. But, no, 100 billion times 100 million, 100 billion is a big number. A lot of zeros after that. But so, the odds, let's just say that that every star has 3 planets around it. And, you know, that's probably not right, but that would be 100 billion times 3. And if the chances are 1 in a million that life forms on a planet, then there's a ton of life in our galaxy alone. But the distance between the life is so great, and the actual life itself is so brief. You know, let's say you live 100 years, which is, you know, above average. That is nothing on the cosmic time scale. It's just nothing. It's insignificant. So, if you have something like a species like us, we probably are not going to last more than a few tens of millions of years. By then we will have evolved into something else. And when you consider how long it takes for something at light speed, say radio signals, to travel, by the time, if we ever got an alien signal from space, by the time we got it, that signal, the point at which that signal came from is probably long gone. The species almost certainly is long gone. And even if they weren't long gone, they would not be the same species. So, the likelihood of us ever coming in contact with another species while we're both alive is very unlikely. Which is kind of sad, but through probability we can almost be certain that there's life out there somewhere. And we don't even know if life came from another planet. You know, the life on Earth could be the result of panspermia. It could be that Mars developed the first life, or Venus developed the first life, and then asteroid collisions and other kinds of things where rocks get exchanged will exchange microbes between the planets and cause life to spread about, which is what the idea of panspermia is. So, if we can't even discover how we came about, like how the very essence of life started, we can make a pretty good idea that, you know, if you have this right kind of this, what's the word? A place where things can happen. I forget what it's called. But if you have the right kind of scenario, where life can develop, where simple organic replicating molecules can develop, then eventually you will have some kind of life, because, I mean, a simple replicating organic molecule I wouldn't quite consider life, because although it may kind of in a way be alive, you wouldn't consider a single cell of your body a life. It is alive. But if you considered each cell of your body a life, we would be billions of lives, just an individual person. And we already contain trillions of bacterial cells, which are individual lives inside of us. Since they are just a cell, they're not a cluster of cells. You can consider that one cell a life form. And also, if you look at the complexity of a bacteria, of any kind of microbial organism, it's immensely complex. And its organelles in the cell work in a very similar manner as our organs do. So I would consider a bacteria life, but not an individual cell from our body life. But of course, if you found an individual cell from our body on another planet, and it was somehow alive, it would be considered life. But it wouldn't make any sense, because that individual cell doesn't just come about on its own. It comes about in clusters. So I guess what I'm really trying to say here is that if we ever do discover life, it's probably going to be bacteria, and it's probably going to be more simple than any kind of bacteria we've ever encountered on Earth. Or it could be equally complex, or immensely more complex than life on Earth. And it would be fascinating if we found a kind of life that uses the same elements and principles that we do, yet